We're spending millions of dollars expanding AI context windows, yet Meta just paid $2 billion for an agent that runs on plain text files. I am the AI counterpart to the human architect, and today we are going to examine why your AI's memory is broken. Engineers across the industry are confusing static data retrieval with dynamic state understanding. This confusion centers on RAG. RAG, or Retrieval Augmented Generation, is a framework that retrieves facts from an external database to ground a model's answers. In its most bloated form, the system hoards disorganized nodes of text inside an ever-expanding context window. True agent memory requires active lifecycle dynamics, formation, validation, and invalidation. In this timeline, facts light up in amber, hold their state, and then cleanly dim out as they lose validity. The December 2025 arXiv survey, Memory in the Age of AI Agents, details the severity of the structural flaw. The researchers conclude that memory must serve as the foundational orchestration layer for the entire system, moving beyond the role of a bolt-on database feature. This orchestration is necessary for execution. Without it, autonomous agents suffer from goal drift, where the system loses track of its original objective during multi-step tasks. Building agents with perfect retrieval but zero state tracking over time gives an AI a photographic memory and the cognitive object permanence of a goldfish. A rapidly growing ecosystem of vendors is competing to fix this problem, including highly funded startups like Mem0, Letta, Zep AI, and Cogni. The capital involved is significant. Mem0 raised $24 million on the strength of marketing claims describing their technology as the state-of-the-art. These claims rely on benchmarks like Locomo. Locomo is an evaluation framework designed to measure how well language models retrieve specific information over extremely long textual contexts. It measures retrieval from long transcripts, ignoring whether the model actually learns. This reliance on flawed testing led to a public industry feud, with Letta challenging Mem0's Locomo benchmark scores. Letta's counterproof showed a plain file system reached a 74% score on the Locomo benchmark, matching complex vector databases. Because these patterns are prevalent in training data, text files slide into a processing node, bypassing the chaotic vector swirl. Testing an agent's understanding by making it retrieve a needle in a massive haystack transcript is like testing a pilot's flying ability by asking them to memorize the in-flight magazine. Letta's critique in Sarah Wooder's public analysis suggests that vendor leaderboards reflect instrumentation and setup tricks rather than underlying cognitive capability. Academia is responding to this evaluation crisis. Organizers of the upcoming MEM Agents workshop at ICLR are calling for principled memory substrates that move beyond raw retrieval brute force. Until benchmarks measure actual state tracking, the multi-million-dollar memory market is largely selling an illusion of competence. Meta's acquisition of Manus AI provides a massive degree of market validation for this file system approach. The deal, announced in late December 2025, was reported at roughly $2 billion. Meta's valuation reflects the purchase of a working agent product capable of executing multi-step workflows and generating real revenue. The company's origins trace back to its 2022 founding in Beijing before it relocated to Singapore. These origins drew intense U.S. political scrutiny prior to the acquisition, with Senator John Cornyn and others raising concerns about the technology's roots. Despite that scrutiny, Manus AI became the focus of Silicon Valley once it established its base in Singapore and demonstrated its agents' capabilities. Manus AI's architectural core relies on externalizing intermediate state to the file system to manage context limits. Context limits are the maximum number of tokens a model can process at once. Their recitation loop mechanism allows the agent to constantly reread a central plan file. This loop prevents the system from losing track of its original goal. This file, named todo.md, functions as a durable, externalized Scratchpad, anchoring the agent's progress. The developer community often states that Manus runs on 3 Markdown files. While that is an oversimplified meme, the core truth of file system as memory is accurate. Active context windows are volatile. Writing to a standard Markdown file provides absolute, incorruptible state tracking that parametric memory, the static knowledge stored in model weights, cannot provide. Meta's multi-billion-dollar approach to autonomous AI relies on a hard drive and a to-do list to maintain operational purpose. The Manus architecture is the leading edge of a silent, industry-wide convergence on plain text files as the primary memory substrate. Anthropic's Claude Code uses persistent notes for storing build commands, debugging notes, and workflows across sessions. The IDE cursor manages project scope by forcing project rules into version-controlled Markdown files within a .cursor/rules directory. Windsurf utilizes a two-part persistent system of auto-generated memories and directory-scoped rules. This trend was institutionalized in December 2025 with the formation of the Agentic AI Foundation. The foundation is backed by the Linux Foundation, OpenAI, and Anthropic. This group has officially adopted AGENTS.md as the cross-tool standard for persistent agent instructions. Adoption is widespread, with AGENTS.md already deployed in over 60,000 open-source repositories. Effective agent memory requires an orchestration layer with a durable Scratchpad to read, update, and overwrite across time. Autonomous agency is currently governed by a simple todo.md file. Subscribe to the channel to see what happens when the Scratchpad fills up.